Good evening. Today is Tuesday, January the 5th. Today in geometry, we looked at the triangular inequality theorem. I'll go ahead and share my screen and show you what this looks like in some problems that we worked with. When you're looking at a triangular inequality, what the triangular inequality theorem says, if you have a triangle here, I can draw this triangle. Let's say this side is 5, and this side is 6, and this side is 7. What the triangular inequality theorem says is that the sum of any two sides of a triangle has to be larger than the third side. So for instance, if we have 6 and 5 here, 6 plus 5 equals 11. Which is greater than 7, which is the third side. Then if you do these two sides, so you'd have 5 plus 7 equals 12, which is greater than the third side, which is 6. And then you use these two sides here, and you would have 6 plus 7 equals 13, which is greater than 5. So if you have a problem where you're given three numbers and you're asked if these three numbers can be the sides of a triangle, then you do exactly what I did. You take any two of them. For instance, let's say we have 4 and 7 and 9. If we add 4 and 7, we get 11. 11 is greater than 9. If I add 4 and 9, I get 13. 13 is greater than 7. If I add 7 and 9, I get 16, and 16 is greater than 4. So therefore, those three numbers can be a triangle. Now, an example of something that doesn't work is something like, let's say we have 2 and 6 and 9. If we add 2 and 6, we get 8, and 8 is not greater than 9. So I cannot have a triangle whose sides are 2 and 6 and 9. Now, the second type problem you have is, let's say, okay, we have a triangle which has sides of 5 and 8. What is the range of values for the third side? So if you look, when you have a problem like this, your third side, which we'll call x, is less than the sum of the two numbers and it's greater than the difference. I'll just abbreviate this DIFF. Okay, so if we look in this case here, x is less than the sum of these two numbers is 13. So the third side has got to be less than 13, and the difference between the two numbers is 3. So it's got to be greater than 3. Now, a type of problem that we run into, or that we do with this, with some variables. So I'll go ahead and erase all of this. And once again, you can pause and look at what I've done. And I'm going to erase all of this. And I'll leave the triangle up here because I can just put some different values on the sides of the triangle. So what I'm going to do now is say, okay, so this side right here will be 4x minus 1. This side over here will be x plus 13. And this side down here will be 2x plus 7. Now, I have to find the limits on x in this case. So, as the triangular inequality theorem says, if I add any two sides, so I'll add these two sides here. So I get 4x plus x, which is 5x. And I add 13 minus 1, which is 12. So that's plus 12. And that's got to be greater than the third side, which is 2x plus 7. So if I solve this, I get 3x is greater than minus 5. So x is greater than minus 5/3. Now, if I do these two sides here, I'll come over here to the left. So I have 3x. 2x plus x is 3x plus 20 is greater than 4x minus 1. So if I subtract the 3x and add the 1, I end up here with x is less than 21. And then the final comparison will be with these two here. So I add 4x and 2x, I get 6x. Minus 1 plus 7 is plus 6. And this has got to be greater than the x plus 13. So if I subtract the 6, I get 5x is greater than 7. So x is greater than 7/5. So what you'll see here, since this over here I had x is greater than minus 5/3, and here I have x is greater than 7/5, by being greater than 7/5, I am automatically greater than this. So this restriction here is not binding. So my final answer here says that x is less than 21 and it's greater than 7/5. So that's the type of problem that you use the triangular inequality theorem and figure out what values of x will make this triangle satisfy that theorem. So if you look at your homework, if you have any questions, send me an email and I'll get back to you. Tomorrow we will look at the last section in this chapter, which is the inequalities involving two triangles. So I'll send you an email tomorrow, or I'll send you a video tomorrow to talk about that. So I'll stop sharing here. Once again, if you have any questions, send me an email and I'll get back to you.